Alrighty, we're going to talk about function compositions in this video. This is going to be lesson 1.4, the real lesson 1.4. The last one was a fake lesson 1.4. That was lesson 1.3 part 2. So let's talk about function compositions. So here's the kind of general way to describe function compositions. You take two different functions and you basically smush them together and create one function by plugging your number into one, getting an answer, and then taking that answer, plugging it into the second function. So here we've got f and g are two functions, and we say f of g, that's what this little circle means. So you would write it something like this, f of g is how you would pronounce it, but you might call it, seen it called fog or goff, but it's really f of g. So this is f of g of x is actually the full thing if you were to say it all out. F of g of x. And that's the same as this notation over here. Both of these notations are interchangeable. The second notation, the one over here on the right, I like because it's really showing you you're taking your answer for g and then plugging that inside of the function f, okay? So what happens first to x? X is an input. Well, x goes into the g machine because that's what's inside. So here's your input x. X is right here. It's going into the g machine. It comes out. The answer to that is g of x. And then that g of x answer goes into the f machine. And the f machine is going to poop out f of g of x. So that's the ultimate answer, be f of g of x. Okay? So it's just taking one function and then plugging that into another function. Here's another picture that you can use to think about it, where we've got some x's, and here's our x to start off with. There's x, and it's going into the g machine, so g is sending it to g of x right here, g of x. And then we're taking g of x and plugging that into the f machine, so that's going over here to f of g of x. That's our last answer, f of g of x. Let's use some colors. G of x. Okay? Okay, so that's basically the moral of function composition. So let's do some examples to get a handle on how this actually plays out algebraically. Okay, so here are two functions, 2x plus 1 and x squared. And so the first function is a linear function, the second function is a quadratic, it's saying square x. Let's compute a bunch of values, f of g of negative 2, f of g of negative 1, f of g of 0, f of g of 1, f of g of 2. So we're basically building a table. And so over here on the left, I have the set of all of our x's, all of our x numbers we're plugging in. So these are our x's. I'm going to highlight them in blue. So these are our x's down here. And we're going to plug these into which function first? Well, the closest thing to x you can see is g. So we're going to plug it into the g function. So we're going to calculate what is g of these numbers. So that's what's going to go into this table right here. So we can try this out. So g, which squares things, remember? G squares things. We should end up getting 4 for the first one, 1, 0, 1, and 4, after squaring each of those numbers, each of those inputs. Lastly, once we've squared each of those numbers, we're going to compute f, which is the second machine we're going to plug our numbers into. And so we're going to take our answers from g, plug those into f, and see what we get. Well, f says multiply my input by 2 and then add 1. So let's go ahead and multiply these numbers by 2 and then add 1. So 4 times 2, or 2 times 4, and then plus 1. And then we have 2 times 1, and then plus 1. 2 times 0, and then plus 1. 2 times 1, and then plus 1. And then lastly 2 times 4, and then plus 1. And so those would be all of our answers. This is going to be 9, 3, 1, 3, and then 9. Okay? So that would be, these all come from applying F to the answers from G. Okay? So, oops, let me get the ink off the slides. So, this is just what I had written down, right? So g of x is squaring each of the inputs, so you can see the answers over here, 41014, and then f of g of x is taking those answers and plugging them into the f function, 2 times 4 plus 1, 2 times 1 plus 1, 2 times 0 plus 1, so forth, to get those last numbers, 9, 3, 1, 3, and 9. So ultimately, the first thing is equal to 9, f of g of negative 2. F of g of negative 1 is 3, this one is 1, this one is 3, and this one is 9. Okay? That's it. Okay, another way you could have solved this problem is to compute a formula for f of g of x. So what would a formula for f of g of x look like? Well, what this says is, remember, let me get my colors right. We're using g of x for the inner one, and using green for the inner one, and red here for the outer one. Remember that g of x is x squared. So wherever we see g of x, oops, let's use green. Wherever we see g of x, we're going to put x squared in there. G of x is x squared. So that means we're going to take this thing over here and substitute it in for g of x. So that becomes f of x squared. So you can see g of x gets taken out, and what it equals, which is x squared, is put in its place. Now we have to put x squared in wherever we see x in the function f. And this might be the trickier one, is I look, okay, here's my f function, remember? Everything I see, everywhere I see an x right here, this is going to get replaced by whatever's inside the function. And so in this case, I'm replacing it with x squared. So instead of 2x plus 1, we're going to get 2x squared plus 1. So this is g of x right here. That's getting plugged into f. So 2x squared plus 1, well, that just simplifies to 2x squared plus 1. And so that's a formula for f of g of x. F of g of x is 2x squared plus 1. So we can use the formula to compute all of those numbers we had earlier. If we were to plug in negative 2, negative 1, 0, 1, and 2, we can try that for a couple of these. What would f of g of negative 2 be with our formula? Well, that's 2 times negative 2 squared plus 1. And hopefully you see that this is 2 times 4 plus 1, which is 9, what we got earlier as our answer. So if we were to do that for all of our values, plug them all in, we get the same outputs. And so it's the same function, because the same inputs give you the same output, so they're going to be the same function. Okay? So either you come up with the formula and then you plug those numbers in, or the other option is to plug them into the first function, plug them into the inner function, find the answer, take that answer, plug it into the outer function. So this is kind of a shortcut, though, that takes you all the way to the end right away. Alrighty. Now, you might ask the question, and I haven't said this, but you can swap the order that you compose things in. You can do f of g or g of f. And all that does is say which function you compute first. F of g which one gets computed first? The g function gets computed first. And g of f, which one gets computed first? F function would get computed first and then plugged into g. So you might ask the question, does the order that you compose these things matter? Are they the same or are they different? The answer is yes, the order matters. They're not the same. Oh god, this is a terrible slide. The answer to this is no. They are not the same. F of g is not the same as g of f. Order matters, so order does matter. They are not the same, okay? So, answer to this question is no. The answer to this question is yes, the order does matter. Okay, let's see why the order matters with an example. So, let's start with a couple of functions. F of x is root x in this case, and g of x is negative x plus 1. So we have a linear function and a square root function. And we're going to try f of g of 4 and g of f of 4. And if order didn't matter, you would get the same answer. But we'll find out that you don't get the same answer. In fact, they're wildly different answers. So f of g of 4, do the first one. We're going to take 4, plug that into g. So 4 gets plugged into g, and so 4 is going to go here, so you're going to end up with negative 4 plus 1, and the answer to that is negative 3. Okay, so g of 4 right here is negative 3. So that gets plugged into the function f, and what we find out is we get square root of negative 3, and that's undefined. So at the end of doing the function composition f of g of 4, we get root negative 3, undefined. Okay, let's try g of f of 4. So g of f of 4 says put 4 into the square root function first, so 4 is going to go into square root. So we plug 4 into x there. Now root 4 is calculable, we get that. That's going to be 2. So in this case, f of 4 is 2. Now we plug 2 into g. We plug 2 into this linear equation over here. So when we plug 2 in, we get negative 2 plus 1. So that's negative 1. That's our answer right there. And so clearly, negative 1 and undefined, two different answers. Order matters. You can't compose them willy-nilly, f of g of 4, g of f of 4. Which function you do first makes a big difference on your answer. In this case, we could not even find the answer to f of g of 4. G of f of 4 had a perfectly good number answer. It was negative 1. Okay, so very different. Okay, let's look at one more example. So suppose we've got these two functions, x squared plus x, so that's a quadratic function, and g of x equals 1 over x plus 1. Alright, so that's a rational function. Pretty simple one. It's like 1 over x, but it's been translated a little bit. So the question is, what are formulas for f of g of x and g of f of x? So we're going to look at two formulas. And from the last slide, you should expect that these answers won't be the same. So our expectation is that f of g of x is not equal to g of f of x. And we'll find out that that's true, that they are not in fact the same. Alright, so let's go ahead and find formulas for both of these. So we'll first look at f of g of x. So f of g of x, I'm going to use some colors here. So let's let g of x be the green guy, and f of x is going to be the red guy. Okay, so green, we're putting the g function inside of f. So g of x is the function 1 over x plus 1. So we're going to plug 1 over x plus 1 into the function f. And whatever goes into f needs to get squared and then itself added to it. That's what this f function is doing we can see that we square the input and we add the input again to itself. In this case, now our input is 1 over x plus 1. So we'll see we get the 1 over x plus 1 squared. So that is right here. And we have 1 over x plus 1 being added to 1 over x plus 1 squared. So wherever you see an x in f, you're going to replace it with the function g of x. So let's simplify this as best as we can. So 1 squared is 1, and so we get 1 over x plus 1 squared is 1 over x plus 1, quantity squared. And then the other term is 1 over x plus 1. It's just 1 over x plus 1. So we can combine these into a single fraction. It's not too hard to do this. We just need to get a common denominator. So that means the numbers need to be the same on the bottom. And so if we multiply the second fraction by x plus 1 over x plus 1, then we'll get x plus 1. Let me write it out. X plus 1 over x plus 1. We're going to get x plus 1 squared on the bottom, same denominator, and x plus 1 on the top. So that's what it will look like after getting a common denominator. So then we can combine these into a single fraction like you would normally, and you'll end up with 1 plus x plus 1 over x plus 1 quantity squared, which is x plus 2 over x plus 1 squared. Okay, so that's f of g of x right there. X plus 2 divided by quantity x plus 1 squared. Now let's look at g of f of x. So g of f of x is now take f, which is our red function, over here. So we're going to take red, f of x, and we're going to plug that into g. Okay? So f of x is x squared plus x. So we'll replace it with we'll replace f of x with x squared plus x. And then we just need to plug that into the function g. And so wherever we see the x in g, so I see an x right here, I'm going to replace it with what's inside the parentheses here. So you can see that it gets replaced with that x right here gets replaced with x squared plus x, because we're plugging the function f into g. Okay? So that's going to give us 1 over x squared plus x plus 1, which is just 1 over x squared plus x plus 1. So if you take a look and stare at these two functions, you'll see they're very much not the same. They don't simplify at all. They're going to have different domains. They'll have totally different graphs. The function over on the right, I believe, doesn't have any asymptotes, whereas the function on the left has an asymptote. So they're totally different, and so composition, the order matters. Okay. All right, now you try an example. Here's two functions, root 2x, so that's 2x inside the root, and g of x is x squared minus 1. Go ahead and try computing f of g of 0, f of g of 1, f of g of 2, and f of g of 3. So I've set up a table for you. You can just try to fill these out. When you've come up with answers to this problem, then you can replay the video and see if your answers match with mine. Remember that the order that you're doing this one is inside and then outside. So g of 0 first before f, g of 1 before f, g of 2 before f, and so forth. Okay? So I set up your table for you. Just go ahead and try to fill this one out yourself. All right. Okay, so go ahead and hopefully you replayed the video. Here's the answers. So g of 0 is negative 1 because we're squaring 0 and subtracting 1, so you get negative 1. G of 1 is 0. G of 2 is 3, and g of 3 is 8. And then f of g of those numbers is going to give you undefined for the first one, 0 for the second one, root 6 for the third one, and 4 for the last one. All right, so hopefully you got those answers as well. Okay, so here's a second you try. Go ahead and try to come up with formulas for both f of g of x and g of f of x. So the first one, you're plugging g in to f, and the second one, you're plugging f into g. And then test your formula for f of g of x, which is the same as the last f of g of x, and compare it with the previous slide's inputs, okay? So test it for those same four numbers, 0, 1, 2, and 3. All right, pause the video, come up with your formulas, and then replay the video when you think you've got the answer. All right, so the first one, f of g of x, that is plugging x squared minus 1 into the function f. And so wherever we see x, we're going to replace it. So wherever we see x, which is right there, we're going to replace it with x squared minus 1. So that's what we get, square root of 2 times x squared minus 1. And so that simplifies to root 2x squared minus 2. For g of f of x, we're taking f of x, the other function, plugging that in to everywhere we see x in g, which is right here. So this guy is going over into the g function. And so we're going to plug root 2x in. And so when we plug root 2x in, g says to square it and then take away 1. So we're going to square root 2x and then take away 1. So we get 2x minus 1 as the answer. So that looks a lot like a linear equation. And so if you had tested your formula, you should have gotten that you got the same set of answers as before. Undefined for 0, 0 for 1, root 6 for 2, and 4 for 3. And that's basically it for function compositions. We'll do a little bit of an example of how can you determine domain and range from function compositions. It's actually quite a bit tricky. Next week, and also talk about how do you take what's a composition, something like root 2 x squared minus 2, and break it apart into pieces, and we'll call that function decomposition, where you're kind of like figuring out what the parts were that came back together. And there's more than one right answer for those kinds of problems. Okay, hopefully that's a good amount of stuff for you guys, and I'll see you on tomorrow in class where we get to practice function composition.